Okay, we're going to look at 3.1 inequalities here. So we have some definitions. Solution of an inequality is any number that makes the inequality true. We're going to look at the different inequality symbols. You've probably seen them before. You've been working with them. We're going to go ahead and define all the different inequality symbols. Less than, we read from left to right, but this is the less than symbol. And if we were to graph something that is, say for example, we graph a value x that is less than 2, we would place an open circle at 2 because 2 is not included in the solution to the inequality, and we would shade everything to the left of it. And so you can see here we read from left to right. If the variable is on the left, then the arrow here, the less than, actually points in the same direction as the graph as we shade it. So that's x is less than 2. All right. Greater than, opposite direction here, we have the greater than symbol. If we say x is greater than 2, we're going to have an open circle at 2 and shade to the right. So that would be x is greater than 2. And you can see that the inequality points in the direction of the shading. It's pointing this way. And the next one is the less than or equal to. You'll notice the line underneath. And so if I had x is less than or equal to 2, I would place a closed circle at 2 and then shade to the left. So values that make this inequality true would be anything like 1.5 would work. Here's 1.5 right here. Or 1 or 0 or negative 0.3 would work. You don't have to just be whole numbers. This shaded line means anything including 2 or to the left of 2. Greater than or equal to, so if I said x is greater than or equal to 2, I would have a closed dot at 2 and be shading to the right. So those are the 4 inequality symbols, and a solution to an inequality is any number that makes the inequality true. So what we're showing on these graphs is that there is an infinite number of values that could make any of these inequalities true. It's not just one number. All right, we're going to solve some inequalities, or write some inequalities first, and then we'll solve some. It says, what inequality represents the verbal expression? It says, all real numbers x less than or equal to negative 7. So here we have x less than or equal to negative 7. If I were to graph that, if this is 0 here, here's negative 7 right here, we would have a closed circle at negative 7 and be shading to the left of negative 7. So negative 8 would work, negative 8.5, negative 7.1 would work. Anything to the left of negative 7, anything equal to or smaller than negative 7, make that inequality true. The next one, it says all real numbers m less than 100. So m strictly less than 100. If I graph that, if you have something like 100, you can just place 100 right in the middle. And really what we care about is the direction as well as the open or closed circle. This would be an open circle. Since the m is on the left, I can use the less than, just like the directional arrow here. Go to the left. And m is less than 100. 6 less than a number k is less than 13. So it says 6 less than a number k. So k minus 6 is less than 13. This time we're writing it something like an equation here, but it says 6 less than. Remember the less than takes the 6 and puts it on the other end of the k. 6 less than a number k is less than, this less than is the symbol, inequality symbol, less than 13. And so that's my inequality. We could then solve this inequality just like we would in an equation by adding 6 to each side. So k is less than 19. And then we could graph the solution set by locating 19 right here, placing an open circle at 19, and shading everything on the number line to the left of 19. Okay, we're going to identify solutions by evaluating. So we're given three different numbers, -3, 5, and -1, and we're asked, is the number below a solution to the inequality 2x plus 1 is greater than -1? So let's take -3. We're just going to do this value by value. We're going to plug -3 in for x. Anytime we plug in a number for a letter, put it in parentheses. So -2 times 2 times -3 is -6 plus 1. And then -5 is greater than -3. So we look at that statement, we say, okay, is -5 bigger than -3? If it were, we would say that -3 is a solution to this inequality. In this case, it is not. -5, I draw on the number line here. See, this is -3. -5 would be 2 units to the left of -3. And so therefore, -5 is not bigger than -3. So this would be not a solution. All right, let's try the next one. Plug in 5 here. So we have 2 times 5 plus 1 greater than -3. 2 times 5 is 10 plus 1. So I have 11 is greater than -3. That one, if I look at the number line, 11 would be to the right of -3. This is -3 right here. 11 would be way over here. And so this is a solution. It makes the inequality true. All right, one more here, -1. We're going to plug in -1. 2 times -1 plus 1 is greater than -3. -2 plus 1 is greater than -3. Here I have -1 is greater than -3. On the number line, if this is -3, this would be -2, and this would be -1. So we can see visually that -1 is bigger than -3. So this is a solution. So you can test solutions in inequality excuse me, one at a time. This is in problem 2. How is the solution of the related equation 2x plus 1 equals -3 related to the solutions of the inequality 2x plus 1 greater than -3? Well, to answer that, we could actually go through the same process we would in solving this one over here. We'd subtract 1. So 2x is greater than -3 minus 1 is -4. And then divide by 2. So x is greater than -2. So the solution process is very similar. The solution set is quite different. In this case, I would end up with 2x equals, if I subtract 1, -4, divide by 2, I get x equals -2. This is telling me on the number line, x is -2. If this were 0, there's -1, -2. Just saying that is the only solution to that equation. -2, if you plug -2 in, it will make that true. Whereas over here, what I'm saying over here, if I draw on the number line the solution set, is that if here's 0, -1, -2, I would be including everything to the right of -2. So actually -2 is not a solution, but anything to the right of it, -1.99, -1, 0, 1, 2. So an infinite number of solutions on this one, only one solution over on this one. All right, so problem 3, graphing an inequality. We've already been graphing them here, but just to show you the solution set, it's typically what we do with an inequality is graph it to give a visual representation of all the values that make the inequality true. So it says, what is the graph of x less than -3? So we would do an open circle at -3, shade to the left. Notice the arrow here, inequality. If that variable is on the left, you can just shade in the same direction as that thing's pointing, but it says x is less than -3. As a matter of fact, on this second one here, I put this one, if you read from the variable's perspective, it would say x is less than or equal to 2. if you want to make sure you get your shading right, just switch that thing around. Go ahead and write it X. Now, when you switch it around, make sure that it's still pointing in the same direction with regard to the variable. So this one has the inequality symbol pointing at the X. It's still pointing at it when I rewrite it. So now this can be used to graph it. Locate 2, close circle there. X is less than or equal to 2, would go that direction. So just go ahead and write it with the variable on the left, and then you can use that kind of like your arrow pointing the direction to go.